thinking about selling his house, and he asks you to help him figure out how much he should sell his house for. So you look in the neighborhood and you see that there are some houses that recently sold in the same area, and here are their prices. So you have between $350,000 and $550,000 and kind of a spread in between. So if his house is about the same as these houses on the list, how do you know what price you should tell him to list his house for? Yeah. Okay, so like you can go to the middle. You know what other advice you might give him? Maybe aim high and let him talk you down to the middle. You know, things like that. Because when you list a price for a house, that's your asking price. Your asking price is not necessarily your selling price. Oh, well. No, what you do is you ask for more than you actually want, and then you let them bargain you down to what you want. Yeah. But you might tell him to go in the middle. Other factors you might consider, if he has more amenities, that might change his comparing to the other houses. Like, yeah, maybe he has a tennis court or a racquetball court and they didn't, or a basement or a fire. Huh? Oh yeah, like the location. Yeah. So anyway, we're going to be using the math that we're going to be using and learning right now is what helps people decide things like this. Okay? These are measures of central tendency. Okay, and central tendency refers to the middle. So if you're talking about the bell curve, it's the tall part. It's where most everything happens. The standard, the norm, the average. Now, if you're talking about your own personal self, you may not want to measure, aim for the central tendency. You might want to, shoot higher than that. But if you're talking about things like this, calculating how much should you ask for your house and stuff, you want to go towards the middle, because if all the houses in that area and they're all about the same are selling between $350,000 and $550,000, and you say, I'm selling my house for $1 million, do you think your house is going to sell?
Nope.
Yeah. So, there's times when you really need to go with the rest of the herd. And this is the math that tells you where the rest of the herd is. Does that make sense? Okay. We have the 3 M's, mean, median, and mode. Mean is another word for average, which is what you're probably more familiar with. I don't know if you guys have heard the really bad math teacher joke. We're not mean, we're above average. So, anyway. Okay, so the mean, median, mode are known as the measures of central tendency. These are the 3 figures that tell us what the central tendencies of the data are. And they act in different ways. So first we're going to do mean, then we're going to do median, and then last we're going to do mode. Okay, so mean is often called the average. Okay, it's the sum of the datas divided by the number of values. It's also called arithmetic mean because we're adding. That's just, if you hear that, arithmetic mean, that's what that means. Most people don't call it that, although that's the technical name. We just say the mean. So what you do is you add up all your numbers. And then you divide whatever you get by how many numbers you added up. Okay? Now, that's what the mean is. Now, symbolically, this symbol right here, X bar, stands for mean, average. So if you put a bar over the X, you're asking for the average. Okay? This symbol right here stands for sum. So when you see that, especially if you're using like Excel and you need to add up a whole column or row of numbers, this is the button that you click and it'll add everything up. It's the sum. That's what that means in math. All these X1s, X2s, X3s and stuff, these are just the different numbers you're adding. and then n is the total number of numbers. Okay, so see how this is x sub 1, that means the first number. X sub 2 means the second number. X sub 3 is the third number. And then x sub n is if you have 15 numbers, it would be the 15th number, and then you divide by 15. Tell your uncle he should sell his house at the average price, the mean. We're going to add up all these numbers. So what I'm going to do is write them down. Does that color show up okay? No, it doesn't really, does it? I don't know, it just looks sort of pretty on this screen. How about that?
Yeah.
See, I'm going to put K's now so that I don't have to write all the zeros. You guys are familiar with the K being thousands? Yeah? Okay. All right.
Wow.
Do you guys know where the K comes from? Kilo. Kilo means 1,000. So this is 475 kilo. So 475,000. Now, how many numbers did I just add up? I have 1, 2, 3, 4, 5, 6. So I have to divide by 6. Okay. So we'll add these up. So 350 plus 475 plus 468 plus 550 plus 378 plus 389 is 2,610,000. Divide that by 6. And the average price of a house in your uncle's neighborhood is $435,000. This is how much he should sell his house for. But we're saying this is how much he should sell his house for. Not maybe how much he should list his house for, but this should maybe be what he's, like this is the amount he wants to end up with. So he would probably list it on the higher side to make sure he got it sold to this price. So not too bad? Cool. Steven's been working at Wendy's for 15 months. And the following are the number of hours that Steven worked at Wendy's for each of the past 7 months. So what is the mean number of hours that he worked each month? Okay, so we have 1, 2, 3, 4, 5, 6, 7 numbers we're going to add. Well, no, he's not. He's a part-time worker. Maybe Steven is in college and he's only supplementing his income and he needs the time to study. Okay, we take our total of 326 and we divide it by 7. And he's working an average of 46.6 hours per month. No, that's per month. So I'm going to add them all up. No, you don't retire until you're at least 65, 67 if you want to collect full benefits.
Daisy. Oh yeah, she's
Okay, the average age of the workers is 428.2 or 427.25. I don't know where I got the 8. All right, for 8 workers, but if they are saying, let's take a sample of 3 employees from the group and calculate the average for those 3. Well, if we just take the first 3, so now we're only using 3, so we take that into consideration and divide by 3. We get 152 divided by 3. because we only added up 3 people, and it goes up to 50.7. But if we picked specifically, I just picked the first 3, and it didn't change all that much. But if I picked 34, 29, and 41, it's going to change significantly. Or if I pick 63, 59, and 55, it's going to change significantly. So if you're taking a small sample, it depends on how you pick the sample, whether or not the average will represent the true group. Does that make sense? So sample selection. So sample selection greatly affects representation. Again, like if I said, like we did this one, if we do 34, 29, I take the 3 youngest. Then if I used this number and they said, so what's the average age of the employees at the shuttle service? Well, the average age is 34.7. No, it's not. Or if you take the 3 oldest, the average age is 59. No, that's not right. 55, 63. Oh yeah, the average age is 59. So then you would have an impression that mostly old people work here. The reason this is important, it's not going to be so much here in what we're doing in this chapter, but the reason this is important to know is because when you are conducting experimental statistics, the statistics that get reported in the news, in journals, polls, things like that, you have to understand it depends on the motivation of the people calculating the statistics. If they're taking a sample from the whole population, if you take a sample that's representative of the whole population, then you get data that's pretty close to the whole population. But if you say, well, I'm only going to pick out these people from the population, or those people from the population, you can make the statistics look radically different from the average of what would be true for the whole population. Does that make sense? Like the polls, the presidential polls, when they're talking about who's in the leads and who's in the leads and stuff, you realize that they're not comparing Democrats and Republicans together yet. The percentages for the Republicans are only amongst Republicans, and the percentages for Democrats are only amongst Democrats. So they're not doing polls yet where they're saying, okay, if you had to vote Trump or Clinton right now, who would it be? They're not, but you see what I'm saying? They're not even asking that question yet. They're saying, if you had to pick one of these Republicans, which one would you pick? If you had to pick one of these Democrats, which one would you pick? So the polls are not giving you an accurate representation of who the people want to be president. They're just giving you a representation out of, oh, well, out of these people, I guess that one. Do you see what I mean? So you want to be really aware of how the statistics have been gathered before you trust them. Because while the math itself is not lying,
It's just not a different way.
how you picked the numbers to calculate the math can give you a different result. All right, so during his final season with the Cadillac Selects, Joe Scher played 14 regular season games and had an average of 24.5 points. Okay, so 14 games, 25.4 point average. Then we add 2 more games and we have 2 new scores. How do we find the average for all the games?
Wait, is it 25
Yes. All right, so how do we find the average now of all 16 games? We want the 16 game average.
So you get 16.
We can't, well, what we can't do is we can't add these three together and divide by 3, because that won't give us the 16 game average. What we have to do is remember that the mean is the sum divided by the total number. Okay. Well, that's what this was. This mean was some sum divided by 14. So to find out what the sum of all 14 games was,
You got divided by 16.
we want to multiply by 14.
Multiply by 14.
Yeah, because multiplying and dividing cancel each other out. And so what we would have then is the sum is 14 times 24.5. Now, I don't know what the individual game points were for those 14 games at this point. What I do know is that when I take all 14 games and add them together, I'll get 343. Okay, so that's the 14 game total. This is the 14 game total. Okay, we had this stat. We knew that his average from 14 games was 24.5. I want to know what is his average from 16 games. I have 2 new game points, but I don't know the points of the individual 14 games that already happened. So, right, there's 14 individual numbers of points that I have no idea what they are. But the sum, the average, the mean, is the sum of all the games divided by the total number of games. So I can find out what the sum of the 14 games was from knowing that there were 14 games and knowing the average. So what I do is I take the average and I multiply it by 14, and that gives me the sum of the 14 games. So I don't need to know what the individual 14 games were. I now know that all together they were 343 points. So far okay? Okay, so then I can take these 14 games, okay, and I can add the 2 new games and get a 16 game total. Yeah, because I have the total of the 14 games, right? I don't know what the individual games were. I have no idea what the individual games were. I just know that all the games together were 343. Yeah. Then if I add 2 more games to it, I now have the sum of all 16 games, which is 387. So now I can find the 16 game average. Yep, I take the total and I divide it by 16. So that will be 387 divided by 16. For an average of 24.2. So his average actually went down in those last 2 games. Barely, but it did go down. Because if we were rounding, this would be 25 and that would be 24. Does that make sense now? A frequency distribution table is used to display organization data in an organized way. And usually what this means is frequency means the number of times a number shows up. Okay? So here's what usually happens when we're doing a frequency distribution is rather than rather than listing all the numbers individually, you'll end up with like a list of numbers, and then you do a tally column to say how many times it shows up. Yeah, like you did with the cards or with the dice. So you say, okay, 10 shows up 3 times, so there's 3 10s in this list, there's 5 11s in this list, there's 3 12s in this list. That keeps you from having to constantly scan and find the numbers individually. Okay. Everybody got that? So the formula for the average, which is what we had before, that's the sum divided by the total number of numbers. Okay. That doesn't take into account numbers that are repeating. Well, it does, but if you have 3 10s, you'd have to do 10 plus 10 plus 10, and then the 5 11, so plus 11, 11, 11, 11, which is kind of a pain. Yes? Adding the same number over and over again, you could, instead of doing 5 11s, accidentally only do 4 11s and make a mistake that way. So what happens is with the frequency table, here we're not using tally marks, we're just saying the total number. It's basically the same formula, but what we have is here's the number, and then this is times the number of times it shows up. Okay? And then the next number times the number of times it shows up. So in my example here, I would have 10 times 3 plus 11 times 5 plus 12 times 3. This is 3 10s, 5 11s, and 3 12s. Without having to type into the calculator 10 plus 10 plus 10 and then typing in 11 5 times. It saves you time and effort. Now what this is the total number of numbers still. And how do I get the total numbers of numbers? Oops. 3 plus 5 plus 3. Here would be a 3 plus a 5 plus a 3, which would mean I was adding together 11 numbers, even though I didn't list out 11 numbers. Does that make sense? And especially when we have a situation like this, am I going to want to add 1 plus 1 plus 1 6 times, and then add 2 8 more times, and then add 3 10 times, and then add 4 13 times? I don't want to do all that. That's a lot of adding a bunch of long numbers, or short numbers, but a long list of adding numbers that is kind of a pain, and I don't want to do it. So what we do instead, here I'm going to, okay, so this would be x1, this would be f1. So I'll do 0 times 1, which is just 0, so I don't even really need to put that in there, but I'm going to put it in there anyway to make sure we follow the process. 1 times 6, 2 times 8, 3 times 10, 4 times 13, 5 times 8, 6 times 5, 7 times 6, and 8 times 3. And then I need to divide all of that by however many numbers there were here. So I'm going to add all these together. I'm just going to put some pluses. So I have 1 plus 6 plus 8 plus 10 plus 13 plus 8 plus 5 plus 6 plus 3. So I'm adding together 60 numbers. So that's what I need to divide by. Okay, so then 0 times 1 is just 0. 1 times 6, 2 times 8, 3 times 10, 4 times 13, 5 times 8, 6 times 5, 7 times 6, and 8 times 3. Divide all that by 60. So I'm going to add all those together now. So I have 240 divided by 60, which means that the average number of books that a student reads is 4 books. Okay. And this is where it's important. When I look at this total, it looks like I'm only adding up 8 numbers. And some people might be tempted to divide by 8. But if I divided 240 by 8, that would tell me that the average student is reading 30 books, as opposed to the average person reading 4 books. It gives me the wrong data. And that's because 10 different people read 3 books, so you have to take into account all of these numbers as well. That's why we total that up. Does that make sense? Same numbers, but here's what's going to happen now. Okay, here's the number of books. Now, you can be presented data like this, and you can go, oh my God, I don't even want to deal with that long list of numbers, right? That's when you make your own frequency table and you do a tally system. So I say, okay, I have 1 0, I have a 5. They don't have to be in order. I just go through and I say, okay, I have 1 5. Okay, here I have a 1. So far I've got 1 of each. I have a 4. Oh, look, I have another 4. I have a 6. So I have 1 6. I have a 7. I have a 2. Oh, look, I have another 4. Right? And we go through the list like this. Here's my first 3. Oh, look, I have another 7. I have another 2. I have another 6. I have another 4. I have another 2. That takes care of the whole first row. Then I said, okay, here's my first 8. And 5, 8, 3, 4, 3, 6, 4. So as I'm going down, I'm just tallying as I come across them. Okay, that takes care of the whole second row. Do you see what I mean? So then, let's say I've done the whole thing. Once I'm done, I'll know I had 1 person picked a 0, and I don't remember how many people picked a 5. So 8 people read 5 books, etc. Now I'm not going to rework the problem because we already worked the problem and it's going to be the same. But I'm just saying, when you see this and you're seeing that numbers are repeating, make a tally so that you don't have to, like, okay, go 0 plus 5 plus 1 plus 4 plus 4 plus 6, that whole front row. You don't want to have to type all that in. It's easier to, when you see you have repeating data, make a tally for all the numbers, and then you'll get these totals, and then you do the problem like this. Does that make sense? Destiny, you have a question?
Okay, so the extra amount, okay, the X is going to be
The number of books.
like the numbers that they have, and then the other one is how many of each there are.
Yeah, so this is, these are the X's.
Okay.
And the F is frequency. Frequency is how many times it shows up. Okay, so using technology to determine the mean of the following sets of numbers. We will go over this on Thursday. I'm going to skip this for right now. We'll go over that on Thursday. So we're just going to do a frequency distribution table of this new set of numbers here that we haven't seen before. Okay. So I'm looking through just quickly. I see a 158, and I want to see if I have anything smaller than that. I don't. So I'm going to start with 158.
We get these surveys back to you?
They're not mine.
Oh, they're not?
No.
They're yours?
Actually, I'm not even going to do it that way. That's the hard way. Okay. All right, ready, guys? Okay, I have a 183. That's my first 183. I have a 171. I have a 158. I have another 171. I have a 182. I have another 158. I have a 164. I have a 183. I've already got one of those. A 179. A 170. A 182. A 183. A 170. A 171. 167 is not on the list, so I'm just going to go ahead and put it up here. And there's 176. There's another 176 and a 164. Another 176 and a 179. A 183 and a 176. 170. 183. 183, 167, 167, 176, 171, 182, 179, 170. Now, did it take me time to tally those up? Yes, it did. But it took me less time to tally those than it would take me to add all that all up and divide by the total. So here I have 5, 3, 6, 4, 2, 3, 2, 3, 4. This one's the 6. This one's actually a 5. I went to make another tally and then I did it. So I have 5 times 176, 3 times 167, 6 times 183, 4 times 171, 2 times 158, 3 times 182, 2 times 164, 3 times 179, and 4 times 170. And all together, I have 5, 8, plus 6, plus 4, plus 2, plus 3, plus 2, plus 3, plus 4. 32 numbers. And I'm just going to double check myself. 1, 2, 3, 4, 5, 6, 7, 8 times 4 is 32. 32 numbers. So I divide by 32. Okay, so I multiply each of these individually. And I'm just going to put dots for that, and I'm going to really do it the fast way on this calculator. We take that 5570, we divide it by 32, and we get an average of 174.06. And that's the average height of a 10th grader, or from this group of 10th graders. Okay, any questions on how to do that? All right. All right, wait. Yes, you do. I own you for 3 minutes.